Okay, so listen up for a second. Guys, Crystal. Our new, guys, please, I gave you munchkins, so now listen to me. Rational functions is going to be the topic of our new unit, Unit 7. As you noticed, it's a lot smaller than the other units, so it's going to take about 2 weeks. I made this little document because I found this really interesting thing about rational functions and how it connects to the real world. Have you guys ever seen a graph that looks like this? Yeah, if you have, this is the graph of a rational function. Today, we're going to learn how to calculate the domain of a rational function, and that domain will tell us our vertical asymptote, which is this dotted vertical line. What do you notice about this line? This vertical asymptote. Do the lines ever touch it? No, the lines never touch it. They approach it. Okay? So the cool thing I found was that rational functions are used to calculate cost of living. Guys, can you stop talking when I'm talking? Medical dosage and economic production of goods. So I found this really cool problem. Can I have the donuts? Jim, take one and let's move on. And then at the end of class, you can get a second one. Okay? Because this is too much of a distraction. Clearly.
I can't get one.
Okay. So I found a really cool formula. This is a rational function, and it represents the concentration of a drug in a patient's bloodstream. I'm not sure. So using this formula will tell you how much of the medication or drug is supposed to be in your bloodstream at a certain amount of time. So they need this formula because what happens if you have too much of a drug in your bloodstream? That's not good. You overdose, which is horrible. What happens if you don't have enough of that drug to treat your disease? It's even worse. So this is a cool way to think about rational functions. They use a rational function to determine how much of this patient, how much of this medicine this patient might need so he doesn't die. Okay? Is that kind of cool? Yes. Okay, so I want you guys to open, when it quiets down, I'll turn the lights off, but it's way too loud in here, so they're staying on for now. Oh, I also want to make an announcement. You guys, your class average for the test was not the highest. It was a 57. So by Friday, you have until Friday to make up this test. If you had below a 70, what do you need to show me in order to make it up? The study guide. So in order to make up this test, you need to show me the study guide and make an appointment with me. You can't just pop in whenever and expect me to be here. I need an appointment made. I'm after school. Guys, I'm after school Monday, Wednesday, and Thursday. So at the end of class, if you need to make an appointment with me, you can. Okay, I want you guys to open up to our first 2 pages. It's a pre-assessment. What I want you to do is take a minute, look through these 8 problems. I want you to write down what looks familiar. If you're able to solve one of these questions, solve them. If there's vocabulary that looks familiar, circle it. So take a minute and digest this information and determine what you've seen before. Have you ever seen the word multiply? Yes, so circle that. Anything about these 8 problems that you've seen. Make little notes. Jaden, what's going on? Does anyone have a pencil Jaden can borrow? Kajaya has one, Jaden. Jaden, Kajaya has one for you.
Hey, you got a good pencil though?
Guys, what are we supposed to be doing right now?
It's gonna work.
or anything about these 8 questions that looks familiar to you. Julio, come on. This is a brand new unit. Let's start off nice and fresh. Take all our notes, do what we're supposed to do. Come on, guys. You should be looking down at your papers, not at each other. Maya, come on, guys. Guys, if this is not able to happen, then you can't sit next to each other. This is not a first time I have this conversation, so let's not let it get to that point. This is a brand new unit. This is a fresh start for some of you. Let's do quarter 4 strong. Well, you've seen some of these words. Well, yeah, that's good. In the corner of your paper, I want you to write 1 through 3, 1 being most confident, 3 being least confident, how confident you feel about what's on these 2 pages. Do you want 1 to be most or least? Okay, so 1 being least confident, 3 being most confident. How confident are you with what you see on these 2 pages? And then I want you to compare with a partner and see if you have the same number. So how confident are you with this information? If you've seen it before, maybe you're not a 1, maybe you're a 2.
I remember doing this like in the beginning. Like I know you saw some things that forgot how to do it. I remember this.
It's good. It's a good start. 1 through 3, guys. How confident are you? I haven't seen one person with that besides Shelly's the only. You have it. DeAndre has it. Are there any 3s? Does anyone feel very confident? Is there any 2s?
Wait.
There. No. All right, guys. We're moving on. We're moving into the notes. Okay, so I want you to turn to the page that says type 1/stamp. And again, until you quiet down, the lights are staying on. So this is, I don't have this on Smartboard, so we're just going to go through this verbally together. Looking at number 1, we have f of x equals x squared minus 3x plus 1. What type of function is that? Why is it quadratic? What do we see? We see squared. So it's quadratic because we have a degree of 2. We're doing this. I don't have it for this, so we're just going to verbally go through. So the first one is quadratic because we have a degree of 2. What about the second one? We have a degree of 2. What is the second one? Why is it linear? Because our degree is 1. Our y-intercept is 8, and our slope is -3. Okay, after class you can do that. Then at the end of class you can do that. What about number 3? Is that linear or quadratic? It's neither. What is it? What do you think? Rational.
What page is that?
This page. Still write it down, but I don't have it on the Smartboard. Okay. Because We'll go into that for the notes, but that's what a rational function looks like. Oh, my goodness. Okay, so let's go through 4 through 7. Number 4 says x squared. Guys, can you stop talking, please, when I'm talking? How am I going to factor this? What two numbers multiply to positive 5 and add to negative 6? Okay, what's my signs going to be? What is it going to be? Two negatives, because negative x minus 5x gives you negative 6x. What two numbers multiply to 9 and add to negative 6? Yes. Five and 4, what are the signs? Yep. What's the last one? Last one's a little bit different. Yes. Why are the signs different? Right, and what's missing? What term? A b term, so that negative 4x plus 4x will give you 0, which is, there's no b term. It's funny. Julio, did you write this in? Can someone give Julio a pencil?
I got a pen.
Here.
Thank you, Miss.
You're welcome. Write this in, please. Actually, I'm going to scroll up, so look at somebody else. Okay, so now we're going to be talking about domain restrictions to rational functions. What is a restriction?
Something you can't do.
Right. What else? What are our other thoughts? What's a restriction? Something you can't do. That's a good idea. Restricts you. Can't go past. Those are really good thoughts. Okay, so this is important. When you're looking at a rational function, in order to figure out the domain, you only look at the denominator. So highlight, circle, put an arrow, something so that you know we're only looking at the denominator right now. When you do look at the denominator, what type of function is the denominator? Linear, right. So we have a linear denominator.
What that mean?
That's going to show us, that's going to tell us how we solve for x. Because eventually what we're going to do is solve for x. What would be your thoughts on what my vertical asymptote is? What is my vertical asymptote? When you look at this graph,
It's 2.
why is it 2? Which line is it? The vertical dotted line. Oops. How did you get x equals 2? I'm sorry, can you repeat that? It passes through the value of 2 on the x-axis. Do these lines ever touch this vertical asymptote?
No, ma'am.
David, turn it off. Do they? No. So then looking at our part A, it says, what x values does the graph seem to be avoiding? 2. Part B says, write the equation of the invisible line the graph is avoiding. x equals 2. So now part C says find a connection between your answer in part B and the denominator of the rational function. So we have x minus 2 being the denominator of the rational function. What do I do in order to solve for x? Add 2. We get x equals 2, which is what? What did we just say it was? It's called something, the vertical asymptote. So now, when we have to write our domain, which is what you're going to do for the rest of today's notes and practice, we would say all real numbers, but x cannot equal 2. Why can x not equal 2? Right. So now that's really good, but now think about our actual rational function they give us, x minus 1 over x minus 2. What happens if x equals 2? If you plugged in x for 2 for x. Looking at the denominator, what if you plugged 2 in for x? The top, so let's do it. So we have f of x equals x minus 1 over x minus 2. So we're going to plug in 2 for x. 2 minus 1 over 2 minus 2. 2 minus 1, 2 minus 2. Can you divide a number by 0? Put it in your calculator, 1 divided by 0. Tell me what you get. It gives you error because you can never divide by 0. This would technically be undefined. So then, knowing that information, why do we say x cannot equal 2? Because what happens if we plug 2 in for x? It becomes undefined. We can never divide by 0. Why do I have an all real numbers here, comma, x cannot equal 2? Because you're right, any number works except for 2. Does that make sense? No? Okay. So this is our domain. This means that we can literally plug in any number into our equation, into our function for x, but not 2, because if we plug in 2, we get our denominator to be 0, and we can never have 0 in the denominator ever. Okay? Have you guys seen this symbol before? All this means is all real numbers. It means the same exact thing as negative infinity, comma, infinity, which you have seen before. This is just a symbol to represent that. It's an R with an extra line through it. Okay? So now we're gonna write a little statement to sum up what we just did. You get this equation / value when you set the denominator equal to 0 and solve, which is what we did. Our next bullet, if x equals 2, the denominator equals 0, and you cannot divide by 0. So you get this equation or value when you set the denominator equal to 0 and solve. If x equals 2, the denominator equals 0, and you cannot divide by 0. Okay? Do you need to drink water?
No.
Okay. Write in these notes. We good? Can I scroll up? Maya, you could turn the lights off. Okay, so now let's look at this. Let's look at the denominator in the second one. We have x squared minus 9. What type of function is that? Quadratic. So we have a quadratic denominator. What else do we notice about this? What's missing? No b term. So how does that tell us how we're going to solve? What are we going to solve? We're going to solve for x, but how? How do we solve falling objects problems? By square root. Exactly. We solve by square root. What are my asymptotes in this question? 3 and negative 3. X equals negative 3. X equals positive 3. So what values does the graph seem to be avoiding? Negative 3 and 3. Yep. What are the equations of these invisible lines? All right, guys, I know it's warm and dark, but we need these notes. They're brand new notes. So try to sit up. If you need to get a drink of water, just ask. Yeah. Okay, so see, we're going to find the connection. So what are we going to do? What did we do in the first one? Set what equal to 0? And how do we solve? Add 9. We have x squared equals 9. Now what? Yep. And what are we left with? Careful. Plus or minus 3. Could we have solved this in a different way? What way is that called? What's that word? How could we have solved this? Factoring. What would we get? Plus 3. And if we set each of these factors equal to 0, we would get the same answer, negative 3 and positive 3. So now, does anybody have any ideas what our domain would be? All real numbers. Why is it not equals instead of equals? How would you get 0? If you plugged what in? 3. Right. So if you plugged 3 or negative 3 into the equation, you would get a denominator of 0. And like we said before, we can't have that. Okay, so one little note, in case you didn't get what me and Maya were saying, if x equals plus or minus 3, our denominator, can I abbreviate to denom? Are we good with that? Equals 0, and we cannot divide by 0. So we have to take these values out of our domain. Did you write that in? Is this making sense so far? Yes. Do we have any questions so far? No. Yeah. No? Yes. What's your question? I could get 3. Okay. So what we did, do you get how we got 3 here? No. Can I see your pencil? It's our vertical asymptote. This is passing through 3. This is passing through -3. What? Oh, okay. Here, we took x squared minus 9, set it equal to 0, and solved for x. You add 9 to both sides, and then take the square root of 9, which is plus or minus 3. Okay? Yep. Why? Okay, number 3. Come on, guys, try to sit up. I know it's warm and it's the day after break, but we got to get these notes in. I'm going to start throwing my ball when they come back. All right, Marcel's going to start us off. Can you get it, please? What type of denominator do we have in number 3? Cubic. The degree is 2, not 3. Quadratic, yes. So we have a quadratic denominator. Just write it above. I fit it. What does A equal? Marcel, you can pass it off. You want to answer the next question? What does A equal? 1. So how are we going to solve this quadratic denominator? How are we going to solve the quadratic denominator? Imad, how are we going to solve the quadratic denominator? Yes. What's that way of solving? Can someone help him out? Julio, how are we going to solve our quadratic denominator? So somebody said quadratic formula. That is possible, but what's an easier way? Factoring. Okay, pass it off, the ball. Marcel, can you pass it to me? Please? I know you know. I want to see if everyone knows. Who wants it? Okay, enough. What are my asymptotes in number 3? X equals 4. There's one more. It's going to be x equals. Look at the 2 graphs and see where they're approaching. Who can help Anas out? What's my other vertical asymptote? 0. X equals 0. It is because our x-axis is always, our y-axis is always solid, so it's hard to draw a dotted line underneath the solid line. Okay, who are you passing it off to? Chastity? Ashley? Ashley, what are x values does the graph seem to be avoiding?
0.
And?
4.
Oh my goodness. 0, and 4. Ashley, pass it off. Guys, Tim, Jaden, come on. If you need to get a drink of water, go get one. Tim, can you sit up, please? We are not here. If you need to go to the nurse, let me know. But we are on number 3. Shelly, what are my equations? Thank you. Okay, you can pass it off. DeAndre, what is my first step going to be to find our connection? Yep. What did we just do? Hold on 1 second. What do we do with our denominator? What do we have to set it equal to? Equals 0, right. Marcel, what's your question? When Brandon comes back. If x equals, what are you asking about the domain? Right, we're just writing it as an equation. We just wrote numbers in A, we wrote equations in part B. No. Right, so you have to write x equals. Okay, 4 is the ball. Yep. David. Okay, this one's a little bit different. We have, Julio, we have a GCF in this one. What is my GCF? Can we pull 2 out of x squared? If we pull 1 out, we're just going to get the same thing. What do x squared and 4x both have? An x, so let's pull out an x. Guys. It's too loud in here, I told you. Okay, so what's my next step? We have 2 factors right now. We have x and x minus 4. Yeah. No. We're not going to distribute. We have to find our x values. So we set each of our factors to what? 0. So we're going to have x equals 0 and x minus 4 equals 0. X equals 0, we're done. We don't need to do anything else. What do we do to get x by itself here? Does this match what we got in part A and B? Yes. So does anybody know what my domain would be? What would my domain be? Look at number 1 and 2, how we found out what the domain is if you're having trouble.
It's
All
all real numbers.
real numbers.
Not equal to. No, I'm sorry.
What did you say?
Not equal to.
What not equal to?
Oh, x not
X cannot equal.
2 4 0, comma 5.
Right. Okay, who has the ball?
DeAndre.
DeAndre, you can pass it off. What is my denominator? What type of function? Quadratic. So we have a quadratic denominator. What does A equal or not equal? What do we know about A? A is 3, so it does not equal 1. So how can we solve this quadratic function? You can pass it off if you want. Jonathan, how can I solve this quadratic function? Which we did is 3, but what's that word of how we can solve? Right, we can factor. What are my vertical asymptotes? You can pass it off. Hector, what's one vertical asymptote? X equals -3. Our next one's going to be a little bit of an estimate because it's not perfectly on a line. So what do you want to say it is?
5.
X equals, it's right after 0, but not quite 1. What do you want to say, 0.4? 0.5, is that what we're agreeing on? Okay. So do you want to say it's less than half?
Yeah.
So what do you want to say?
Like
0.5. What?
0.3?
Say in the middle.
Okay, Jaden. What X values does this graph seem to be avoiding? You just wrote it down on the board. Look, we boxed it in. Your eyes hurt? I'm only turning off the light if it quiets down in here. What are my X values? All right, Jaden. And not 3, 0.3. So we have -3 and 0.3. I think she's doing stuff. So what for part B? What are my equations? Jaden, you can pass it off if you want. X equals and we're not 100% sure about this, right? So we're just going to put a question mark?
Okay.
Okay. Now what's my next step?
I don't know.
Hector, what's my next step? What do I do with my denominator? What's my next step?
Yeah.
What do I do next for part C? (3x squared). And what do we set that equal to? 0. Okay, Hector, you can pass it off. Gilberto, how am I going to factor this?
Miss, wait, is this 3x squared together or not?
Yeah. What's going to go here? You want to put x here? 3x and then x. What are my factors of -3? 1 and 3. Where do you want to put the 1? Where do you want to put the 3? So let's check. What's my inner? What's my outer? Which one has to be negative for us to get to a +8? The 1. Okay, so are we done? What do I still have to do to find my domain? Set what to 0? So 3x minus 1 equals 0, and x plus 3 equals 0. How do I solve for x for my first one?
You add 1.
Add 1. Now what?
You subtract 3.
So x equals 1/3. How can I write that as a decimal? 1/3. To do 1 divided by 3. What is it? 0.33333. So if we round to just the 10th place, we get 0.3. Does that match what we thought it would be?
Yeah.
Yes. How do I solve for x with this part?
Subtract 3.
Subtract 3. So I'm left with x equals -3. Does that match? Yes. So can we write my domain?
Yeah.
Yes. What's my domain?
Numbers. I like no this equals 3. Negative. Yeah. -3 and 23.
What's your question? The domain?
Yeah, like if you have it right here, why do you have to go that?
Because if they're asking you specifically for the domain, you have to write in the domain. We have to do all this work in order to get to the domain. So you'll see on the next page, they'll give actual problems where you're just finding the domain.
Oh, okay, so like if the graph was there?
Right, so the part A and B are just relating why we're doing this to how it looks on a graph, which is our vertical asymptotes. Okay? Okay, so we're going to take a couple more notes before we move on. 1 minute? We got way farther in the other class. Okay, we're still going to go. Rational.
I'm gonna get lunch right now.
Yeah, but take it.
No, when the bell rings, you can get them.
I didn't get one.
You are on what I call
If you're not working till the bell, you can't have any more munchkins.
I gotta do this and that.
I didn't get one.
When the bell rings. Come on, guys. Okay, so the question's asking, why did these x values need to be avoided, thus causing a domain restriction? So why? Yes, because 0 can't be in the denominator. Guys, your homework is to work through these problems as well as these problems.
Wait, which one? The next page?
These,
In the back page?
and then the other page, yes. All right, you guys can finish.
I could finish.
No, not you can't have them, Jaden.
Why can't I have any?
Take these on your way out. Oh.